In this program, we're going to talk about the birth and death of stars, about the possibility of life on other planets, and the means man has at his disposal to observe and study the universe. The first way you can observe the sky is to look at it with the naked eye, without using an optical instrument. And the first thing you will discover is that the stars occupy the same place in relation to each other in the sky, night after night, year after year. They seem countless, but a careful observer can actually see over 2,000 stars at the same time. Their grouping into shapes representing mythological gods, heroes, and animals dates back to antiquity, but we still use those 88 constellations today. Hercules, Cassiopeia, the Big Dipper, Cygnus. Our solar system came into being roughly 4,700 million years ago as part of a galaxy which itself began to form 14 billion years ago. The universe's time frame is quite different from ours, but within that time frame, stars have a life of their own. They too are born and die. Stars are born as a result of one of the universe's greatest forces, gravity. Gravity affects huge cosmic clouds of gas and dust. Through phenomena we know little about, gravity makes the cosmic clouds contract under the pressure of their own weight. When this occurs, the friction between the gas particles of the cloud, made up chiefly of hydrogen, heats up the core of the cloud. The temperature and pressure of the gases rise to such an extent that the hydrogen atoms blend together. This reaction, nuclear fusion, produces new chemical elements and emits an enormous quantity of energy in the form of heat and light. A star is born. Depending on its mass, the star will radiate a red, yellow, white, or blue light. The star reaches the end of its life when the nuclear fuel that feeds it begins to dwindle. Deprived of energy, the nucleus of the star cools and contracts. At the same time, its exterior layers swell disproportionately, as much as 100 times its original diameter. The star takes on a red color. The dying star becomes a red giant. What happens then depends on the star's mass. If, like the Sun, it is not very massive, it will contract again and become a faintly shining star, called a white dwarf star, which will eventually die. The same fate awaits our own Sun in 5 billion years. The fate of stars at least 10 times more massive than the Sun is, on the other hand, completely different. When their nuclear fuel runs out, their matter is subjected to such a powerful magnetic force that they contract unto themselves at amazing speed. In a mere few thousandths of a second, a colossal shock wave goes through the star, causing a gigantic explosion. A supernova just lit up the universe. A supernova releases so much energy that its brightness can, for a several-day period, exceed that of an entire galaxy. In 1987, a supernova appeared in the Magellan Cloud, one of our neighboring galaxies. Observations astronomers made at the time enabled them to learn a great deal about these rare and spectacular astronomic occurrences. Once it has exploded, all that remains is an extremely dense nucleus, several dozen kilometers in diameter. The density of this star, called neutron star, is so great that a teaspoonful of the matter it consists of would weigh 1,000 tons. Because of their minute size, some neutron stars spin at high speed, rhythmically pulsating light and ejecting matter. We call these space beacons pulsars. A more dramatic fate awaits the more massive stars. Once the nuclear reaction stops, the star collapses under the influence of gravity. It continues to collapse until the totality of its mass is concentrated in a minute dot. The star becomes a black hole. Black holes cannot be observed directly, as usually they emit no light. Even so, most astronomers are convinced they exist. According to theoretical calculations, black holes would have extraordinary properties. Their gravity is so strong that no object could ever escape them. Even the light a black hole radiates is drawn back into it by sheer pull of attraction. In a way, black holes could be considered warps in the time-frame web that weaves our existence. By Einstein's law of relativity, for example, time inside a black hole would appear to be almost at a standstill to an observer located outside the black hole. Scientists even believe that giant black holes, into which entire constellations vanish, might be the centers of some galaxies, including ours. The stars are far from being merely silent witnesses of our earthly activities. They play a crucial role in the evolution of the universe. Most of the chemical components of planets and living beings were produced by supernovas. In essence, we are no more than spin-offs of the stars. Often, the birth of a star will provoke the natural formation of a planetary system that will gravitate around it. Here is how our solar system came about. In the beginning, a gas and dust cloud under the influence of its own gravity took the shape of a disk. The sun was the first to form. In the cloud of extraneous matter that revolved around that primitive sun, atoms of rock and metal came together until they constituted a big enough mass to be able to attract other masses by gravitational pull. These masses agglutinated together until they formed planets. Very quickly, life appeared on the planet third closest to the sun, in a mere 800 million years after the planet was born. Since there are other stars in the universe, hence other suns and other planets, how do we know that life doesn't exist elsewhere as well? Our planet is the stage of an extraordinary natural phenomenon, life. Planet Earth sustains such a great variety of forms of life that you can't help wondering if other parts of the universe don't sustain life as well. A science, exobiology, has arisen from questions like these. For a number of years now, exobiologists have been gathering clues that would indicate that life does indeed exist on other planets. That life on Earth evolved from the simplest substances is one of the arguments supporting that thesis. Over 3 billion years ago, the atmosphere of Earth had no oxygen, only toxic gases such as methane, hydrogen, and ammonia. Streaked by lightning, it let the sun's ultraviolet rays through freely. Such hostile conditions caused the gases in the atmosphere to blend, thus forming complex molecules. These molecules accumulated in the seas, where they assembled in tiny droplets called coacervates. Coacervates, easily reproduced in laboratories, have the ability to absorb chemical substances. Some molecules absorbed by coacervates assembled to form nucleic acids. Nucleic acids have the unique property of dividing and transmitting their characteristics. Coacervates inherited such properties from the nucleic acids and multiplied. The first living cells came into being. These cells produced the oxygen in our atmosphere and grouped together to form more and more complex organisms. Most scientists believe that life on Earth did not occur at random. Favorable conditions simply made it possible. Did this evolution, which took millions of years to happen, occur anywhere else than on Earth? To date, there is no evidence that it did. Life-sustaining conditions do not appear to exist on any of the other planets in our solar system. In 1976, the United States' 2 Viking space probes set down on Martian soil. None of the biochemical analyses carried out by these devices gave any evidence of life on the red planet. However, scientists do believe that life-sustaining conditions might well exist on other planet systems, or even in interstellar space. Complex carbon-based molecules have been discovered in the cosmic gases. Carbon, which can produce long molecular chains like those of nucleic acids, is precisely the basis upon which life on Earth evolved. Could these molecules be telling us that life forms are evolving among the interstellar clouds? Could be. But what really seems to suggest the possibility of extraterrestrial life is the sheer immensity of the universe. Our galaxy alone holds at least 100 billion stars. According to the most conservative estimates, 20,000 of them could have planets inhabited by one form of life or another. Some scientists take this line of reasoning further. They maintain that life-sustaining planets could be home to intelligent beings living in highly technologically advanced societies. In recent years, several projects have been launched in the hopes of communicating with extraterrestrial beings. For instance, the American probe Pioneer carried a message indicating to possible aliens the Earth's position, nature of its inhabitants, and even our peaceful intentions. In various parts of the world, powerful radio telescopes listen to our galaxy. Computers analyze the waves received, attempting to discern possible messages. The techniques used are so sensitive that they would enable us to capture hypothetical television programs broadcast on a planet light years away. Conversely, using techniques similar to ours, extraterrestrials could receive our TV shows. So far, all attempts made to communicate with other civilizations, often at considerable expense, have ended in failure. So why don't we just give up? Probably because deep down we hope that we are not the only forms of intelligent life in the whole universe. While radio telescopes have not been able to put us in touch with extraterrestrial beings, they have let us tune into the stars. Thanks to these tools, we have discovered astronomical phenomena we knew nothing about. Yes, heavenly bodies emit radio waves. Radio telescopes are part of a plethora of instruments we use to gain additional knowledge about the sky. Behind all that technology lies man's determination to observe the sky to figure out where he came from and where he is going. Since antiquity, our knowledge of the stars has grown by leaps and bounds. We owe our progress in large part to the development of powerful cosmic observation tools, telescopes. Of all stargazing instruments, the optical telescope is the best known. Most large optical telescopes, called reflection telescopes, are equipped with a large mirror. This parabolic-shaped mirror captures the light emanating from a star and focuses it onto a smaller, flat mirror. In turn, this mirror reflects the light onto an ocular situated on the side of the telescope and against which the astronomer can place his eye. In this way, the telescope enlarges the images of visible celestial objects, such as planets. But its main function is to pinpoint the presence of distant stars and galaxies that shine too feebly for the naked eye to perceive them. Visible light received by an optical telescope only represents a tiny portion of the radiance stars emit. A large portion of the energy stars radiate comes in the form of radio waves. Fortunately, instruments have been developed that are capable of picking up these invisible radiations: radio telescopes. A radio telescope is equipped with a large metallic antenna in the shape of a parabola. It directs radio waves from the sky toward a receiver in its antenna. The signals captured are then analyzed in such a way as to constitute a radio image of the sky. To equal the degree of sensitivity of optical telescopes, radio telescopes have to be extremely large. The diameter of the world's biggest single antenna radio telescope measures 350 meters. The precision of these instruments can be made even more accurate by connecting several antennae together on rails. It was radio telescopes such as these that led to the discovery of quasars, which are cosmic objects transmitting fantastic quantities of energy. Quasars are thought to be the nuclei of galaxies located at great distances from the Earth. Astronomers now have at their disposal highly sophisticated means with which to analyze optical and radio telescope data. From an image of a very remote galaxy obtained through an optical telescope, computers can highlight, through a play of colors, the less luminous areas of that galaxy. Those areas correspond to gas and dust clouds, which could camouflage major accumulations of non-visible matter. Data from a radio telescope can be used to study the movements of the galaxies. Since the Big Bang that created the universe, the galaxies have been moving away from each other at a rapid pace. The various wavelengths galaxies transmit provide an indication of the speeds at which they are moving away. It is also possible to reconstitute a galaxy's rotational movement in space. These techniques enable the astronomer to examine, while comfortably installed in a laboratory, the characteristics of a galaxy thousands of light years away. In fact, Most astronomers today spend most of their time making calculations and developing mathematical models of the stars. However, the long nights spent at the controls of immense telescopes still constitute a vital aspect of their work. Based on what scientists know today, it would seem that sooner or later all the gas and dust remaining in our galaxy will concentrate to become stars, and eventually there will be nothing left to form new ones. The universe continues to expand and the galaxies to disperse. But who knows? Perhaps in 50 years' time, a new theory will give us a whole new perspective on what future our universe can expect.